morning, everyone. And for our title, SINAG, the Sustainability Innovations for Nurturing Adaptable Growth in Filipino Space Habitats. Let me introduce our next speaker, Dr. Paulus Hernandez. He is also the Vice President of the Philippine Space Bioscience Society Incorporated. Dr. JP is a Filipino-American nursing scholar who pioneers aerospace nursing by bridging nursing, communication, biology, and aerospace physiology. He is the first Filipino associate professor and associate dean of simulation at Helene Fall College of Nursing in New York City and holds the Certified Healthcare Simulation Educator credential. His research spans COVID-19 in infodemics, AI humanoid robots in healthcare, and nursing student stress and with publications in biomimetics in 2024 and the Journal of Medical Investigation in 2025. He has earned the Provost Faculty Leadership Award in 2024 and Vicente Tevez Locsin Junior Research Award in 2022. His work includes data sonification of cosmic anomalies and Soundscapes of Nursing Care or the ICN Congress in 2025. He contributes to a NASA-funded mushroom growing system for space missions, serves as Nurse Research Fellow at the Advanced Space Life Research Institute. He is also the Vice President of the Philippine Space Bioscience Society, as I mentioned, and leads an international CubeSat project on moss resilience in space. Okay, and allow me to introduce Dr. Joans Paulus Hernandez. Doc, good morning po.
Hello, good morning to everyone. I hope you can hear me from your end. Please let me know if I need to make any adjustments from my audio.
Yes, Doc, loud and clear po.
Loud and clear, Doc.
Thank you. So let me share my presentation. Let me just move this around. Okay, then okay, can you see my screen?
Yes po.
Okay. Let
Yes,
me just
Doc.
let me just move this thing. Okay. And it seems my controls are frozen. Okay, there. So my presentation is titled SINAG. I purposely turned off my video camera so that I would be encountering any problems as I advance the slide because it takes a lot of resources with video, audio, and then sharing my media. So my goal is to pivot around what has been done already, which can be applied to Filipino ways of living in space. And that brings us now to using biology and then what can be threaded to healthcare so that we could sustain life in space. So I declare no conflicts of interest in my presentation. And as mentioned, currently I do have two projects, and one project is with NASA. And I'm working with other scientists, particularly engineers, to bring reality of mushrooms to be grown in outer space. We would start growing the mushrooms outer space on the International Space Station, which has never been done in a scale and in a system where we could grow mushrooms in a closed loop system. So my affiliations, as a faculty member, I teach in the School of Nursing as associate professor for nursing research and statistics. Currently, I'm still completing my master's degree in aerospace physiology at Case Western Reserve University. And then other affiliations would be being an alumni of NASA L Space, which recently concluded in our cohort, for our cohort rather, in spring 2025. I'm also a volunteer research fellow for the ASRI organization, where we conduct and provide opportunities for research regarding outer space, applying health and then reproductive medicine in outer space. But my take on that is more on nursing and then bringing on aerospace nursing, how we could start caring for astronauts as nurses. As you all know, nurses are not part of the major stream for NASA jobs, most likely space medicine. So we would want to put nursing where we could work with astronauts and become astronauts ourselves. So recently, I put up my own company, and my goal is to further how nursing could actually takes its shape and form its roots in the space industry. So initially, it was introduced as aerospace nursing technologies, but because of the state regulations, it has to be revised, and then now the company which I have founded would be called Stellar Life Support Technologies, which would be a nurse-led aerospace company. I believe it's the very first kind of business entity where nurses can actually make use of sciences to bring healthcare to space, starting from education and training. I do have two current projects. I did mention one, something to do with the moss, and the other one has something to do with developing satellites or designing at least the concept of how we could send satellites and bring on board the satellite, watch the effects of radiation and microgravity by using our sensors on board the small satellites. So we plan to bring MOS to suborbital experiments using satellites. So at the moment, this is where I'm at. I have the control for the experiment, and the experiment is about mycoponics. We do have mycoponics system already on Earth, but we never had a mycoponics system for outer space. So as part of the team, as one of the scientists, I have the control for the experiment. So the control would be using traditional solid or physical media to grow mushrooms. So we're using wood chips to demonstrate mushrooms can grow in comparison with other substrates to compare whether they can degrade other substrates, namely, let's say, paper waste, animal manure, um, maybe inclusive of other mixtures, probably plants that are added to the mix, which are supposed to be representing now agricultural waste. So microponics would work when you have a liquid substrate and the liquid should flow within the system. If you would see on your end comparison of how mushrooms would grow, but the thing here is we're doing an Earth experiment where gravity alterations in gravity hasn't been into effect, but it has been theorized that mushrooms can go in any directions, depending on orientation. So we will get to know how well the system would work, considering that the system would be designed to scale for the large requirements over time for the astronauts. So the equipment needs to supply the astronauts with food. The other issue with mushrooms on space, not all astronauts would want to have that taste of mushroom, which would be described as spongy. So we're working with scientists who are actually working at NASA in developing and ensuring quality production of space foods, working with them in a way where we could actually process the mushrooms and address also concerns about palatability and maybe come up with, our own culinary approach with how to prepare the mushrooms on board the International Space Station. So microponics has been demonstrated on Earth, and this represents now other scientists who are actually interested in growing mushrooms. So the picture that you're seeing, this is actually the system that has been implemented and is still currently being developed for optimization at Purdue University. So the scientist behind here at Purdue University is one of our consultants for growing our mushrooms on the International Space Station. So I'd like you to see a short clip where we could actually redesign the concept where you have a liquid medium or liquid substrate flowing into growth chambers. Our design is more compact because it has to be flyable to the International Space Station. So let me play the video for you to see how we could actually circulate the fluid.
Traditional mushroom farming requires a substrate, a layer within which the mushrooms feed, live, and grow. That substrate is discarded after one use. Mu mycology uses a reusable substrate scaffold onto which a nutrient-rich liquid medium is injected. The scaffold is then inoculated, producing mycelium, a substance that gives rise to mushrooms. The mushrooms are harvested, and the system repeats itself. This highly efficient cycle continuously produces food in a small area, just the ticket for astronauts voyaging in deep space.
So we are actually along the same concept, but we tweaked the design so that we will be using cylinders. So we got the funding from NASA on April 24, 2025. If you would see in the picture, I'm the only nurse participant uh, in the team, and the rest are engineers from different kinds of engineering specializations or background in terms of training as well. I would say the very first Filipino nurse to be part of the NASA design team for producing sustainable food source by designing a system that could actually be working in a cycle, which could also be run by AI in terms of sensor monitoring and then data collection. So this is just a representation of how we envisioned the system to appear. Though I cannot show you the exact design because uh, we have non-disclosure agreement as part of the member of the team, and that has already been underway for NASA further development and will be patented later on. So initially, we thought of this kind of concept, and of course, imagine something more compact as compared to this one. But as an update, we started with 10,000 US dollars. That's a seed funding. It's not a huge amount of money. And then recently we got second funding, and the second funding would enable us to purchase 3D printer and then to scale into the required volume or size because for us to bring this to the International Space Station, It doesn't have to be just like a size of a shoebox. It has to scale up in terms of dimension. And we also thought about scaling in terms of number, having more systems on board. My work in this project, I'm the data scientist. So I do predictive modeling, I do computer simulation. So this was the initial model which we submitted, which we got the approval for funding. And when we say sustainable resources, that means to say something that can work by itself. And the other purpose of bringing mushrooms to the International Space Station is to help in the efficiency of water recovery. And water on the International Space Station or in outer space is far precious than gold. So anything that's effective would have to be 95% or higher in terms of recovery. And based on simulation, computer modeling using quantum computations, which I did, it did serve the purpose that it could work by 95%, 95.56% for water recycling. Um, our project rose to TRL 7, and TRL 7 means to say technology readiness level. If you reach like 7, it is flyable to outer space. So we were also not expecting that we will have an accelerated development given a short period of time, because NASA became so interested about this one, and they thought this could work, and we got the support of the people behind NASA who would want to help us scale the project. So our trajectory for the mushroom growing system. So the project is going to the International Space Station next year in 2026. The official date hasn't been announced yet. We cannot publicize the final design until after November of 2025. And then the next phase would be a consideration of bringing the mushroom growing system for the Artemis mission, and then much more distant to the Mars project by NASA. The second project, which would represent Filipino ingenuity in terms of sustainable um, research, the quest for sustainable research that includes data gathering and analysis, that includes as well informatics in space, will be the development of cube satellites, will be less expensive than building bigger scale satellites. In my recent work, since I am pioneering aerospace nursing, there are many other researchers who are into aerospace nursing. From their background, of course, they're nurses, or something to do with allied health medicine. But I just wanted to show everyone, based on the model, if you look at the way the interactions of the variables, nursing, environment, health, and person, this is how we create our nursing theories. So yes, we could care for the person, but for us to get into sustainable development in outer space, nursing requires engineering. Of course, nursing by itself doesn't have any engineering courses. So development of a curriculum for space nursing would require engineering, so that we could do countermeasures for the effects of outer space to human physiology. These are the following focus areas for um, my talk, particularly in assuming a sustainable future in outer space that will be livable, not only for Filipinos, but for everyone who wants to go to space. So the engineering focus obviously would be life support and technologies that would be helping us to design habitats that can withstand weathering. Focus for medicine would be disease prevention, more likely epidemiology, and then the effects of zero gravity or microgravity. Of course, focus for nursing is to address caring in a sense that we care for the total person. And then the roles specific to nurses based on the scope of practice, which we could do, which would be in tandem with the practice of medicine. And then communication also to how are we going to disseminate the objectives of going to space, And then, of course, that requires public awareness, and that is requiring now how to language the desire and then the science behind having settlements extraterrestrially. And of course, there's also an emphasis to arts. We also consider arts to be part of human civilization. And how do we communicate those things that are not covered by science to engage the public for greater interest? As an example of what arts would be like, which would still be based on science, this is the work of my one of my researcher colleague, and then they're looking into showing the effects of DNA damage upon exposure to radiation as when their models for life in biology, biological studies can be interpreted in terms of an art display. So this has been exhibited already, and just sharing with you the organism that they use for studying the effects of radiation and gravity to the DNA of the organism. These are the gaps or the problems that NASA has at the moment, based on the 2024 full report. And then to name them, I call them pain points. These are the things that we need to do. So if you do have research that you want it to be funded, or you want to do some kind of research aligning to priorities of NASA, these are the things. Radiation in terms of material science, in terms of electrical systems, robotics, space communication, better life support, health monitoring and protection, and then, of course, radiation shielding. These are the concepts which I think would be more helpful to understand how to become sustainable in outer space. And there are three sciences that maybe you have already have heard or have been able to read. So to be sustainable, we should be able to apply the following sciences. It was already presented a while ago: astrobiology, bioastronautics, space bioprocess engineering, or it's more tied to space manufacturing. So this is just the world map where the sciences are actually growing. If you look at the Philippines, we do not have much emphasis on these sciences because it's not mainstream. That's why Filipino needs to study abroad or to do their studies and research abroad, because we don't have this much resources that could actually support our scholars and even those who are interested to go to space sciences. I did network analysis. This is actually from the literature. So my goal is actually to re-examine the data and see like what are those things that would matter a lot for Filipinos, um, trending to what is being shown in media, where I mean in social media, where a lot of people, particularly most of them are females, going to wanted to go to outer space. Then for them to have these, they must be able to have focus areas or skill sets related to the following sciences. So if you look at my analysis, of course, the thicker the lines, they're the most important context in the literature. So you have there in situ resource utilization, and then that's tied to space flight, and then affecting now by space factors, for example, microgravity. And on the other side, you have synthetic biology, where you bring whatever, let's say, bacteria that you could modify, or other organisms that you could genetically modify or tweak to increase their adaptation or to optimize them. So furthermore, I used quantum annealing to condense those important things based on themes, and then the most important themes narrowed down would be resource utilization and biological research. Of course, that also would require structures or infrastructure. But if you wanted to focus more on astrobiology, it's more on biological study or explorations of organisms that can actually thrive, that includes now human beings, how we could be optimized. And then, of course, not relying on the traditional linear supply chain. That means to say we have to grow our own crops, we need to build our own tools from whatever we can find on the moon or on Mars. So to differentiate the different kinds of sciences, which would be overlapping for the knowledge purposes of comparing and at the same time understanding where could be the clear cut. So we refer to space life research science. It's broad. Space biology is more focused on the effects to biology, and then space biosciences or space bioscience or the study would be more on systems biology, more on a systematic approach to put it all together. Now, to put them into a structure, you would notice that space biology and space biosciences are linked by bioastronautics. So if you wanted to pursue life support systems, that would include now development of spacesuits, climate control, developing habitats, that would require bioastronautics, which nursing doesn't have at the moment for us to serve the purpose of helping furthermore the caring capabilities that we used to have here on Earth to extend it to outer space. So to further narrow down the terminology, so astrobiology, which has been um, presented by growing crops on a different planet, is more on prebiotic chemistry and microbial chemistry. For bioastronautics, it's more on support systems and countermeasures. And then for space manufacturing, which we call bioprocess engineering, is more of the use of biotech and then resource utilization. Now, the goal of sustainability, from the word sustainable, we are not relying from Earth supply. So definitely nothing should be wasted. So waste we could reuse. It's not a typical recycling process that we could do on Earth. When we consider about recycling, then we also need systems how to degrade the waste and how to recover what we could materially and molecularly. So this pertains to what we call a circular economy, a space-based circular economy, which will be more efficient. So we're building this kind with our mushroom growing system. And there are two important aims to decrease reliance for Earth supply and transitioning from a visitor to a long-term resilient inhabitant of another planet. What are the ways we could address to get into circular economy level? Of course, we need to master how to recover resources by extracting materials from waste and then developing a closed loop system. So similarly, mentioned for crop to be produced or crops sustainability, that's actually termed or contextualized as space farming, which we have been under that category, space farming and space manufacturing for the Mushroom Forge project. Then we also need to consider components that would make people or make other life forms alive. So that would pertain to life support systems. And then the closed loop systems have to be very efficient, that we do have minimal wastage that includes now energy or heat. As an example of what we could consider as natural products, which we could incorporate in many countermeasures. So this is one, the use of ash from rice straw, which we do have because we have rice agriculture in the Philippines. And then we also have abaca, the fiber, though it's not included in the slide, but I just wanted to share that that can be used for thermoregulation for spacesuits. And of course, that would be tied with nanotechnology to better now the performance of the abaca. To continue on with circular economy, we need to have a sustainable life cycle management to promote circularity and additive manufacturing, which in another way of saying is 3D printing. And then the last would be in situ resource utilization, which is using soil on the moon or using dust or using rocks or regolith to build shelters on the planet. So when we say building space habitats, though there are many literature about better ways to design them, but to simplify, uh, these are the important things that should be part of the plan. How to create an artificial climate within the shelter. So that means to say not only ensuring that there will be oxygen, but also to scrub, carbon dioxide, and then how to balance the gases. Water purification system, nutrient cycling for biological waste, and then material reprocessing. Let's say your parts or machines would break down, which is expected, so how can you make use again of the nuts and bolts and other parts so that you could actually use them to build other tools, which would be essential because instead of finding raw ingredients, then you could reuse materials. These are my recommendations based on the literature review on how we could have SINAG, how we could be sustainable and innovative to promote livable habitats, specifically addressing the way Filipinos are in terms of the way we live culturally and the way we perceive environment. So first would be use of microbes and plants and the use of smart technology to control climate, which I would say using now AI and machine learning. Uh, Other than saying it's automation, but it's more on intelligent kind of workflow with the use of advanced computing. So I did mention that anything that's effective for water recycling should be at least 95% and much better if it's more than 95%. So space farming, think about growing our own Filipino crops. To name a few, for example, kangkong, malunggay, pechay, kamote tops. I know kangkong would require more water, but if you could genetically modify the kangkong to thrive with lesser amount of water, or whether kangkong can actually grow with liquefied waste, and then consider also other crops to experiment on them if they can work in the same way, and that would be great. For protein source, of course, mushroom would be a good source for protein. And then another example here is spirulina, which would also be addressing not just eating the food, but also having a good microbiome in the gut, because that's actually tied to health and wellness of the astronauts. Space manufacturing for 3D printing, which you could 3D print a shelter, makeshift. You could also 3D print small parts. So I would say 3D printing should be part of courses in high school and in college. It's not just 3D printing because it's for special projects. If we could actually master additive manufacturing, and of course with knowledge and skill on how to use computers to design, for example, CAD designs, uh, that would be very important for us to be engineers of our own trade. So nurses can also create, diagnostic tools with 3D printing, and that can also be parts of our simulation equipment. Just to show the picture of what it means to be sustainable. So it's a cycle. That's why it's called circular economy. And everything is altered in outer space. You could imagine the vastness of alterations in physiology. And then furthermore, to recommend the use of whatever can be discovered, for example, water on the moon. If we could actually source it, then that would be um, be very vital for sustaining life, which water is very precious. And then that would be used also to build stations on the moon. We need also to consider protection, occupational health of people working on space habitats or those who are joining the mission, particularly from galactic radiation or cosmic rays. Reliability as well of the system. So there's a consideration of systems design, systems integration, systems engineering in particular, where whenever one part would break down, then it could still work with other parts of the system. So that's something more complex to think about, but it could start with, simple build. Let's say it does point to a number of redundancies in the system. If you think about, a fail-safe mechanism, biomining and aggressive recycling, which is also an important thing to source materials locally. When I say locally, locally on the moon or locally elsewhere. This is an example on how an embankment can be constructed from rocks or a soil. You could actually use robots to build a huge 3D printer using whatever materials that can be compacted on the surface of the planet. So to think about whether you have your bright idea, whether it would work, I'd like to share a tool which is free, which you could use to simulate, let's say, if you have one plant, two plants, or other organisms, how well would they sustain the habitat. This doesn't become very specific to Filipinos, but uh, based on the cosmic footprint, we do say carbon footprint where we're on Earth, but in the way that would be better describe mapping, how much consumption would be the term cosmic footprint. So I did simulation with let's say, with my recommendations with Filipino habitats becoming sustainable, I use a nonlinear approach using quantum algorithms just to simulate it. So you need to consider that over time, if you have a lot of people, then they would use a lot of oxygen, so that would lower down, and then there's a rise of carbon dioxide. So to countermeasure this, you must balance both biotic and abiotic to make sure that you can replicate the cycle, which of course will not be exactly the same on Earth. But at least if you could design a system using all those elements, then that would be a breakthrough. It was mentioned something like, if I heard it correctly, some kind of a bioreactor. So biomass would pertain to, organisms like plants. Uh, in our case, mushrooms. So how well would that serve for the purpose of sustaining life? So if you look at the graph, yes, there's a point where one simulation is better than the other, and to narrow down what it means. So we need to stabilize the carbon dioxide levels build up. And then if you notice from the graph, there are no fluctuations, at least keeping the carbon dioxide at a predictable rate. And then the use of plants, particularly algae, and then considering that they could grow steadily, would not actually slow down, the progression of your habitat reliance on consumable resources, which algae can actually provide not only oxygen, but can also be a sustainable food source. Now, the thing that you could use with your simulation is what we call CMOC. CMOC is free, which you could download with, I mean, you could actually run it online. I haven't encountered it's downloadable for the purpose of installing in your desktop. So let me just uh, fix this one just to remove this thing up front so that you could see um, the dashboard. So when you go to CIMOC, you can actually start your simulation as a guest. And then you do have preloaded data. Either you want to simulate your biology experiment, either on Mars or Biosphere 2. You could work loading the simulation data, or you could customize the data. So once you're on the website, you just move to loading and then ask a guest, or you could actually create your account. Then it leads you to this nice visualization. If you notice, you do have here a picture of your habitat that you wanted to build. In this case, it's on Mars. And then on the other side, you could customize here how many humans are actually in the crew. And of course, the ECLSS is actually the life support system. And then Radish, we know that's the representation of the plant. So you could actually change the settings here, and then you could simulate like how much consumption over a period of time, considering what is present on Mars. Then you could input how many food would you want to test in terms of weight or volume, and then how many modules could be installed or in store coming from the original mission for life support. Then you would have this kind of dashboard where you could see all the simulation, and let me show how it exactly looks like once you have loaded your data. So this is a 2-minute capture of the simulation. There's a video tutorial. You could YouTube the video tutorial on CIMOC, and then you could work on looking at the different parameters on the side, which you could actually change if you do customize the input. So this would be something I think would be very useful for everyone. If you have a thought experiment, at least you could predict like how much gases could be produced. That includes now human waste to be produced over a period of time. And I find it very interesting the moment this was shared to us in our recent meeting with our NASA project. And then we could actually use the same tool to predict the outcomes of using mushrooms outer space based kind of solutions for sustainable development. So far, that's the only thing I have for my presentation. Not all references are listed here. These are the references for the initial slides. And then if you do need the references for those recommendations, I would be very happy to provide them to everyone. Thank you. Maraming salamat po. So if you want to connect, this is my profile on LinkedIn, and then my email if you want to send me a message to ask questions, or would you want opportunities to find a pathway working with at or addressing your career trajectory, thinking about NASA and other NASA opportunities, then you could shoot me an email. That's it.
All right. So thank you so much po, Doc JP, no?